A function f takes an input x and returns an output y, which is shown graphically using this curve and also over here. Now to go backwards, we take the inverse of y, which is the inverse of f of x, and that gives us back x. So that's shown over here, and we can also show this graphically over here. Now for the inverse to exist, the function must be bijective, meaning that every x value maps to exactly one y value. So for example, if x3 also mapped to y1, then the inverse would not exist, because we don't know which direction to go when we take the inverse of y1. And that can be seen using something like this. Now to find the derivative of the inverse function, we just differentiate both sides. And on the right hand side, we simply have the reciprocal of dy dx. So we can use the derivative of the original function to find the derivative of the inverse function. Let's find the derivative of the inverse of this function. So using this relationship that we derived, the derivative of the inverse function with respect to y is equal to the reciprocal of the derivative of y with respect to x. So differentiating y, we can obtain the following expression. Now we're asked to evaluate the derivative of the inverse function at y equals 2. So therefore, if we solve this equation for x, we get the following expression. And we're given a condition that x is greater than -1. So we'll take the positive root. So at y equals 2, x is equal to -1 plus root 2. And if we substitute this into this expression, we can evaluate the derivative of the inverse function at y equals 2. Which is equal to 1 over 2 root 2.